Hello everyone, we are presenting our functional programming mini project titled on the carbon emission calculator. This system is implemented using Haskell and focuses on estimating carbon dioxide emission based on the transport, electricity and fuel usage. The project demonstrates the key functional programming concepts such as pure function, immutability, recursion, algebraic data types, and modular design while addressing a real world problem related to environmental sustainability. Let's see the project structure overview. Our project is organized into multiple modules to ensure the clarity and maintainability. Uh, Main Haskell source file, data types file, processing HS file, and utils HS file. Each file has single responsibility which aligns with the functional programming best practices. Let's see the file-wise explanation. In the main Haskell source file, it is the entry point of the application. It contains the main function which simply calls the menu interface. All computation and logic are delegated to other modules, keeping this file minimal and clean. Let's see the next file, which is data types file. uh, this defines algebraic data types such as transport, electricity, fuel, and emission report. These types model real world entities and enforce type safety, preventing invalid data from being used in calculations. And in the processing HS file contains all the pure functions responsible for calculating carbon emissions. Each function takes input value and return a result without any side effects. Because the functions are pure, the calculations are reliable and the predictable and easy to test. Let's see the input output handle source file. It's handle all the input output operations, including displaying the menu, accepting manual user input, reading CSV file, and also printing formatted results. Separating input output from the computations keep the functional core pure. In the utils file, contains helper functions such as emission level classification. This avoids the code duplication and improves the reusability. Let's see the code based interface, how this programming is running. This is the Haskell console program. All input and output occurs in the same terminal window. We design like that, and there is no separate GUI window. The program uses line based input and menu driven interface guides the user through the process. Let's run the process and let's see how this project is working. As the first command, we have to run the program using the GSCE Glasgow Haskell compiler. Let's type the command and let's see what is happening. uh, by using this command, we can load all the files, uh, as you can see, and after that we can run the main file. Let's run the main file here. As you can see, the main file is running and the menu appears, allowing us to select the input method. Let's go through with the option 1. In our project, we design through two inputs like manual input and the CSV file input. Let's see the first input type, that is manual type input. Uh, in here, the user has to enter the transport distance, electricity usage, and fuel consumption. Let's see here transport distance and the electricity usage and the fuel usage in liters. After that requirement is entered, you can see the system calculates the carbon emission for each category and the total CO2 emission level, CO2 emission, and the emission level such as low emission level, medium or high, as according to the calculation. As you can see uh, with these features, the level of the emission is the low emission. Here is the input for the manual input. Let's see the second one, which is the CSV file input. We can input the enter the CSV file path, which is in the according to your desktop or laptop. The file need to enter the exact file location. This program reads multiple records from the CSV file and process the immutably. This demonstrates the functional data transformation pipelines commonly used in the industry. As you can see, according to the input CSV, all the emission levels are automatically calculated by using the CSV file data. This is the final outcomes that we received from the carbon emission calculator. This project demonstrates the several key functional programming concepts: pure functions for the calculation, algebraic data types for modeling data, recursion instead of loops, and also immutability with no mutable state, and the modular and reusable code. Here are the features make the system safer, easier to test, and more maintainable. Let's see the industrial relevance. This application is relevant for industries involved in sustainability reporting, carbon footprint analysis, and environmental monitoring. Here is the simple demonstration for the our project, which is the carbon emission calculator. We implemented for the manual input and also the CSV input. See, in the CSV input, it is automatically generated the emission levels and the uh, emission levels and the emission according to their data. uh, Thank you.